In this video from ITFreeTraining, I will look at how to configure Windows storage spaces for Windows Server 2012 R2. Windows Storage Spaces allows you to combine multiple storage devices to form the one space for performance, redundancy, and administration reasons. In this video, I will look at the following. First, creating a storage pool. When you create a storage pool, you have the choice of either allowing Windows to automatically allocate physical disks in the pool to virtual disks, or doing so manually. I will be having a look at the advantages of both options. Next, I will be looking at the different types of layouts that can be used for virtual disks. This also includes the new layouts for three-way mirror and dual parity included in Windows Server 2012 R2. Following this, I will look at how to remove a working physical disk from the storage pool. In most cases, this will be because the physical disk has failed. However, sometimes you may want to remove a physical disk that has not failed. Next, I will look at how to extend a virtual disk. Essentially, this means making the virtual disk bigger, which you can do at any time. Next, I will look at how to replace a failed disk in the storage pool. Sometimes physical disks do fail, and you want to be able to cleanly remove the failed disk while ensuring the storage pool still has the required redundancy. Lastly, I will look at storage tiers. This is a new feature in Windows Server 2012 R2 that allows you to combine mechanical hard disks and solid-state drives together, taking advantage of speed differences for better performance. I will now change to my computer running Windows Server 2012 R2 to look at how to configure Windows storage pools. To start with, I will first right-click on the Start icon, select the option Run, and then run Diskmgmt.msc. This will run Disk Manager in full screen. Once loaded, notice that there are 7 physical disks that have been installed in this system. These physical disks range in size from 50 GB to 100 GB and 200 GB. The sizes do not need to be the same to be used with Windows storage spaces. To configure Windows storage spaces, I will next open Server Manager. Once open, I will select the option File and Storage Services. This will be installed by default on your server. If I select the option Disks, this shows all the physical disks that have been detected on the system. This includes physical disks that are in use with Windows storage spaces and those that have not been used and cannot be used. For example, the hard disk used for the operating system. Windows does not support booting from Windows storage spaces, so the disk containing the operating system cannot be used with Windows storage spaces. If I select the next option down, Storage Pools, this will show any storage pools that have been configured on the system. Currently, there are no storage pools that have been configured. You will notice that under Storage Spaces, the free disks are listed under Primordial. Primordial essentially means existing from the beginning of time. Despite the interesting name they chose for it, existing Primordial is all the available physical disks that have not been allocated to a storage pool as yet. Although I personally do not think free physical disks need to be listed under storage spaces, as they are not part of a storage space yet, I think Microsoft's logic for doing this is to give you something to right-click on to be able to select the option for New Storage Pool, like this. Once selected, the New Storage Pool wizard will start. Once I am past the welcome screen, I need to enter in a name and description for the storage pool. In this case, I will enter in General Storage for the name and the description. On the next screen, I need to select which physical disks I want to use in the storage pool. In this computer, there are 7 available physical disks, and I will select all of them. None of these physical disks have been used, so there is no data on them. If your physical disk does not appear in here, check that all the data has first been removed from the physical disk, including any volumes. Notice that there is a pull-down option under Allocation. The default is Automatic, which allows the storage pool to use the physical disks as it sees fit. The next allocation option is Hot Spare. This option prevents the physical disk from being used in the pool. The hot spare is only used if another one of the physical disks was to fail. As soon as a physical disk fails in the storage pool, the hot spare will change to automatic and data from the other physical disks copied to the hot spare. Thus, the hot spare acts as a spare physical disk and is only used when another physical disk fails. The last option, manual, allows the administrator to select how the physical disk should be used rather than have Windows storage spaces make this decision automatically. Notice that when this option is selected, an informational message is displayed at the bottom of the screen. This message indicates that it is not recommended to use automatic and manual allocation in the same storage pool. To understand why, consider this. If you had Windows storage spaces configured with 7 hard disks, 4 of these are configured for automatic allocation and 3 configured for manual allocation, the following would happen. Virtual disks could be created with simple two-way mirror and single parity for both the automatic and manual allocation. However, three-way mirror and dual parity would not be available. This is because three-way mirror and dual parity both require 5 disks. In this case, even though there are 7 hard disks, neither allocation has 5 disks. For this reason, it is recommended to use automatic or manual, but not both. Later in the video, I will create some virtual disks in the storage pool. If you have both automatic and manual allocations, you will get the following dialog. On this dialog, you will need to select which allocation to use. You are not able to select physical disks from both allocations. If you do not have enough physical disks in the allocation, this selection will limit which options you can choose for the virtual disks. You can see that the advantage of using the manual setting gives the administrator the choice of which physical disks will be used. This gives the administrator more control over which physical disks are used, whereas with automatic, the administrator does not need to worry and Windows will make the required choices. In this example, since I want to have all the physical disks available to me, I will change the option to automatic and move on. The last screen of the wizard will give you a choice to confirm the settings. Once I press Create, the storage pool will be created. The storage pool does not take too long to create. Once the storage pool has been created, I can close the wizard. Now that the storage pool has been created, if I right-click on the storage space, I can select the option New Virtual Disk to start the new Virtual Disk wizard. Once past the welcome screen, I need to select which storage pool to use. In this case, I only have the one storage pool. However, you can create as many storage pools as you want. Unless you have a good reason to, it is generally easier to have the one storage pool and place all your free physical disks in that storage pool. Windows can support up to 160 physical disks in the one storage pool. On the next screen of the wizard, I will enter in a name and description of the virtual disk as Simple Disk. On the next screen, the layout of the virtual disk needs to be decided. I have 3 types to choose from. In this case, I will select Simple. There is more information about the layout on the right of the screen. Simple layout will divide the data from the virtual disk amongst all the disks in the virtual pool. This gives the virtual disk excellent read and write performance, however, offers no redundancy. If any physical disk in the storage space was to fail, you would lose all the data in the simple virtual disk. For this reason, simple disks are usually used for temporary storage space or data that is easy to recover if lost. Often, they will be used for video files since high read performance is required and since videos are generally static. Once created, they are easy to back up. On the next screen, you can decide the provisioning that is used for the virtual disk. The default Fixed will create a virtual disk the same size as what you specified. For example, if you enter in 100 gigabytes, 100 gigabytes of space in the storage space will be used. If you select the first option, Thin, which I will do in this case, the virtual disk will use only a small amount of initial space. As data is added to the virtual disk, it will get bigger. Thin provisioning is a good choice when you require multiple virtual disks and you are not sure what your storage needs will be. It allows the virtual disk to grow as your needs grow and stay small if the space is not required. On the next screen, I need to enter in the size of the virtual disk. In this case, I will enter in the value of 50 gigabytes. Once I enter in this value and move on, I will be at the last screen of the wizard, where I can press Create to create the virtual disk. The virtual disk should not take too long to create. Once created, I can close the wizard and the new volume wizard will start up. This will allow me to format the virtual disk and configure a volume label on it. Once I'm past the welcome screen, the wizard will display the server and virtual disk that is to be used. On the next screen, I need to enter in the size of the volume that I want to create. In this case, I will accept the default option, which will use all the available disk space in the virtual disk. The next screen will allow me to select the drive letter I want to use. In this case, I will accept the default of E drive and move on. The next screen allows some formatting options to be entered in. In this case, I will enter in the volume label as Simple Disk and move on. The next screen will allow me to confirm the options that I entered in, and once I press Create, the virtual disk will be formatted and available to the operating system for use. The process should not take too long to complete. Once complete, I will close the wizard and then go back to disk management. Notice that the new virtual disk has appeared as Drive E. Also notice that the other 7 physical disks that were displayed here earlier have disappeared. Once the physical disks have been managed by Windows storage spaces, they no longer appear in disk management. I will now go back to Server Manager and create a second virtual disk by selecting the option New Virtual Disk under the Tasks menu in the Virtual Disks section. The procedure is the same as before. I will go past the Welcome screen and Storage Pool selection screens until I get to the Virtual Disk Name screen. On this screen, I will enter in the name and description, which in this case will be Mirror Disk. Once I move to the next screen, I will select the layout for this virtual disk as Mirror. On the right is information about Mirror. To use it, you need a minimum of 2 disks that will keep running after one disk has failed. If you want to use a 3-way mirror, this will keep running after 2 physical disk failures. On the next screen, you can choose 2-way or 3-way mirror. The option for 3-way mirror will only appear if there are enough physical disks in the storage space to support it and you are running Windows Server 2012 R2. In this case, I will select 3-way mirror and move on. The next option gives the choice for thin or fixed provisioning, from which I will select thin provision again and move on. On the next screen, I will enter in the size as 30 gigabytes. Notice at the bottom of the screen is an information message stating that the virtual disk may use some additional space for write-back cache. This improves performance of the virtual machine and is used on Mirror and Parity virtual disks. On the next screen, I can check the settings used before pressing the Create button to create the virtual disk. Once the wizard has completed and the virtual disk has been created, the new volume wizard will launch itself again. The wizard is the same as last time, so I will accept all the default options until I get to the File System Settings screen. Once I enter in the volume label of Mirror Disk, I will change the file system to REFS. Windows Storage Spaces integrates with REFS, taking advantage of its features. REFS is designed to be a self-healing file system and corrects problems as they occur without having to unmount the file system. There are some features not implemented in REFS that were included in NTFS, and thus you should see if you require these features before making the switch. The most noticeable missing features are EFS, compression, and disk quotas. With the options configured, I will now complete the wizard and the volume will be created on the virtual disk with the REFS file system. Now that the volume has been created, I will go back to Server Manager and select the option New Virtual Disk to create the last virtual disk with the Parity layout. Once again, I will go through the wizard accepting the default options and setting the name and description to Stripe Disk, as this is effectively a stripe disk with Parity. In hindsight, it would have been better to call this virtual disk Parity Disk. On the next screen, I will select the option for layout as Parity. On the right side of the screen is information stating that the Parity option requires a minimum of 3 physical disks, but needs 7 physical disks if you want to protect the virtual disk for 2 physical disk failures. Since I have enough physical disks, on the next screen I have the option of single parity or dual parity. In this case, I will leave it on the default option of single parity and move on to the next screen. Notice on the next screen, I have the option of fixed or thin provisioning. Rather than move on in the wizard, I will instead move back to the previous screen of the wizard. On the previous screen, I will select the option Dual Parity and move on to the next screen. Notice that the option for thin is now grayed out. If you want to use Dual Parity, you will only be able to use the fixed provisioning type. On the next screen, I need to enter in the size of the virtual disk, which for this case, I will enter in 20 gigabytes and move on in the wizard. Now that the wizard is complete, I will press Create and create the last virtual disk type. On the final screen of the wizard, I will de-tick the option Create a Volume when this wizard closes. This will create the virtual disk, however, no file system will be created on the virtual disk. This step will need to be performed later on using disk management. Since I have created some virtual disks in the storage space, it would be good to get an indication of how much space has been used. To do this, right-click on the storage space and select the option Properties. Once the properties are open, notice that there is a bar indicating how much space is currently being used in the storage space. If I select the Health option, notice that at the top, the health status is indicated as healthy and the operational status is listed as OK. If I go back to Server Manager, I can get some additional information about each virtual disk. If there are any problems with the virtual disk, they will show up here. And also, you can see how much space is being used by the write-back cache. On the right-hand side, you can see the physical disks that are present in the storage pool. If I select one of the disks and right-click on it, I have the option to remove the disk. Perhaps you want to replace the disk with a larger one, or maybe it is starting to fail. When I attempt to remove the physical disk, I will get a message indicating that Windows will attempt to rebuild the storage pool using the other physical disks in the storage pool. If there is enough data from the other physical disks in the system, it will be able to do this. Notice, however, that when I attempt to do this, I get a message stating the operation could not be completed because of a simple disk existing on the physical disk. Simple disks have no redundancy and will spread their data out using the available physical disks in the storage pool. If you use the simple disk layout, make sure you are aware that you will not be able to remove physical disks from the storage pool later on unless the simple disk is removed first. This is another reason why simple disks tend to only be used for temporary data or for data that is easy to restore. In order to remove the physical disk, I will first remove the simple disk. Notice that when I right-click on the simple disk and select the option Delete Virtual Disk, I will get a message indicating that the volume on the virtual disk needs to be removed before the virtual disk can be deleted. To do this, I will go back to Disk Management, right-click Simple Disk and select the Delete Volume option. Once I confirm that this is what I want to do, the volume will be deleted. Now if I go back in Server Manager, next I need to go up to Tasks and select the option to Refresh. Once the screen has refreshed, I can now right-click on the simple disk and select the option Delete Virtual Disk. Now that the simple disk has been removed, I will now attempt to remove the disk. Once I select the Remove Disk option, I will get a message indicating that Windows will attempt to move all the data from this physical disk and store it on other physical disks in the storage pool. Notice that when I press Yes, I will get another message indicating that the process was not successful. Windows will attempt to move the data to other physical disks in the storage pool while making sure the required redundancy is kept on the virtual disk. In this case, the storage pool has a dual parity configured, which requires 7 physical disks as a minimum to operate. I have 7 physical disks in the storage space, so if I remove one, the dual parity virtual disk will not be able to operate at the required redundancy level, as it requires 7 physical disks. To get around this, I first need to add another physical disk to the system. When removing physical disks from the system, you need to consider if, once the physical disk is removed, will there still be enough physical disks in the system with free space available to ensure the required redundancy level is maintained. If this is not the case, the operation will fail. To remove the physical disk, I first install another free physical disk to replace it. To do this, I will pause the video for a moment while I install another physical disk. So don't go anywhere, I'll be right back. Now that the extra physical disk has been installed, I will go up to Tasks and select the option Rescan Storage. A message will appear indicating that this may take a while to complete and other tasks may not be available while this is occurring. I'm happy to wait, so I will press Yes to continue. Notice now, if I select Primordial, I can see the physical disk I just installed on this system. If I right-click on the storage pool, I will select the option Add Physical Disk and add this physical disk to the storage pool. It is just a matter of ticking the physical disk and making sure that the allocation option is configured to Automatic. Once I press OK, the physical disk will be added to the storage pool, and I will now be able to remove the physical disk that I attempted to remove earlier. Notice that once I press Yes, Windows will change the usage of the physical disk to Retired. Windows has removed the physical disk, but has given an information message indicating that you should not make any additional changes while it is still servicing the storage space. Essentially, Windows Storage Spaces is still making some changes. However, this should not take too long, as there is no data stored on the virtual disk. The next feature that I would like to point out is that a virtual disk can be made bigger after it has been created. To do this, right-click the virtual disk and select the option Extend Virtual Disk. Once selected, it is just a matter of entering in the size that you want to extend the virtual disk to. There is, however, no option to shrink a virtual disk. Once I select OK, notice that disk management will take focus since a change has been made to one of the physical disks in the system. You can see the mirrored virtual disk is now 60 gigabytes and is divided into 2 parts. The virtual disk has been extended. However, the volume on the virtual disk is not using all the free space since it was originally created when the virtual disk was smaller. To use all the free space, I will right-click on the volume and select the option Extend Volume to launch the Extend Volume wizard. Once past the welcome screen, on the next screen I can enter in the size I want to extend the virtual disk to. Notice that by default it is configured to 60 gigabytes and thus will use all the remaining space. I also have the option to combine multiple disks together. I will not be doing this as I believe it is better to combine multiple disks together using Windows Storage Spaces rather than using disk management. Once that wizard has been completed, the virtual disk will now be using all the free space. So you can see that extending a virtual disk is a 2-step process. If I go back to Server Manager, What I will do next is show you how to replace a failed hard drive. To demonstrate this, what I will do is remove one of the physical hard disks from the computer. Once I have removed the physical disk, I will go up to Tasks and perform a refresh. Notice that under Physical Disks, the first physical disk now has an exclamation mark next to it, indicating that the computer can no longer communicate with it. Also notice at the top, there is an exclamation mark next to the storage pool, indicating a problem, and also an exclamation mark under virtual disks. Since there is redundancy in the storage pool, the virtual disks will be able to operate even after the loss of one physical disk. If I open the properties for the storage pool and then go to Health, notice that the operational status for the physical disk has changed to degraded. To get the storage pool operating again at a healthy state, I need to replace the failed physical disk. If I go back to Server Manager and right-click one of the failed virtual disks and select the option Repair Virtual Disk, Server Manager will accept the command. However, the virtual disk still has an exclamation mark next to it. Windows is not able to repair the virtual disk due to there not being the required number of physical disks in the system to maintain redundancy. If I select Primordial, notice that the physical disk that I removed earlier is available, so I can use that physical disk to replace the failed one. So I will right-click on the storage space and select the option Add Physical Disk, and select that physical disk. The difference this time, I will set the allocation to hot spare rather than automatic. This tells Windows that this physical disk has been configured to replace any physical disks in the system that are failing. Once I have added the physical disk, notice that it appears with the others, except the usage is marked as hot spare. If I once again right-click a physical disk and select the option Repair Virtual Disk, this time notice that the physical disk is being repaired. The process does not take too long in this case because the virtual disk has not had any data put on it. Notice that the physical disk is still listed as hot spare. However, if I go to Tasks and perform a refresh, notice that the physical disk is changed to automatic. If I now select the second virtual disk, I can select the option Repair Virtual Disks, and this virtual disk will also be repaired. Once it is completed, notice that the physical disk that I removed from the system is now reported as retired. This means that the physical disk can safely be removed from the system, which I will now do. The last feature that I will look at is storage tiers in Windows Storage Spaces. This feature is only available in Windows Server 2012 R2. Storage tiers allows you to divide your virtual disks into a solid-state part and a second part that will use traditional mechanical hard disks. Windows will automatically optimize data so the data that is used more often is stored on the solid-state drives rather than the mechanical drives, improving performance. If I look at my physical disks, notice that each one currently has status of unknown. Hopefully your physical disks will detect correctly and will not appear as unknown. If this is the case, you can configure the media type using PowerShell. So I will now open PowerShell from the Quick Launch bar to do this. The first command that I will run is get physical disk. This will show all the physical disks currently installed on the system. I want to take the output from this command and filter out physical disks 2 through 4. Disk 1 was removed due to failure, and disk 0 holds the operating system. To do this, I will press up to get the last command, and then add pipe, followed by where friendly name -like, and then physical disk. Notice that to select disks 2 through 4, I will add 2-4 in square brackets. When I run this command, notice that it will show physical disks 2, 3, and 4. I next need to use the output from this command and pass it to another command. To do this, I will once again retrieve the previous command and, this time, add the pipe command followed by set physical disk dash media type HDD. Once I press this command, it will configure disks 2, 3, and 4 as hard disks. Now that this is done, I will change disks 5 through 8 to solid state. To do this, I will retrieve the previous command and change the media type to SSD, and then cursor back and change 2 to 4 to 5 to 8. Once the change has been made and the command has been run, disks 5, 6, 7, and 8 will now be solid-state drives. If I now exit out of PowerShell and perform a refresh in Server Manager, notice that the disk media types have now changed. To create a new virtual disk using tiers, I will right-click on the storage space and select the option New Virtual Disk. I will accept the default options in the wizard until I get to the screen Virtual Disk Name. On this screen, I will enter in the name and the description Tier Drive. To create a tier virtual disk, I need to tick the option Create Storage Tiers on this virtual disk. This option was previously not available, as the media type of my physical disks was not configured. Once I move on to the next screen, I will need to select the provision type. Simple and Mirror are available, however, Parity is not. In this case, I will select Mirror and move on. On the next screen, I can choose two-way or three-way mirror. I will keep the default option of two-way mirror and move on. On the next screen, notice that thin provisioning is not available, and there's also an information message at the bottom of the screen explaining this. This also applies to the simple layout. Unfortunately, if you choose tier storage, you are limited to fixed provisioning. On the next screen, I need to decide how large the virtual disk should be. Notice that there are two parts, the SSD part and the HDD part. For the SSD, or faster tier, I will enter in 20 gigabytes, and for the HDD, or standard tier, I will enter in 60 gigabytes. Notice that down at the bottom of the screen, the total size of the virtual disk is listed as 80 gigabytes. Once I press Next and then press Create, the virtual disk will be created using tier storage. Once the virtual disk has been created, if I go back to Server Manager, notice the tier drive has been added and a tick has been added to tier storage. The tier drive is now ready to go. That covers it for Windows storage spaces. Quite a long video, but I am sure you can see the advantages and features that Windows storage spaces provides. Thanks for watching, and I hope to see you in other free videos from us.